In this video, we will learn about the linear programming problems. This is the introductory video on the linear programming. The definition of linear programming is one that is concerned with finding out optimal value, that is either maximum or minimum, of a linear function. We call that objective function of several variables, let us say x and y, subject to conditions that the variables are non-negative, that means x and y are both greater or equal to 0, and satisfies a set of linear inequalities, what we call the linear constraints. Okay, so to understand it better, let's take a simple example. Let us say we have a person. Okay, we have a dealer who deals in two items. Let us say what we call tables and chairs. Okay, we have a person who deals in tables and chairs. That means he buys the tables and chairs and then sells them. Okay, so we have item here, table and chair. Let us suppose that cost per unit of table and chair is being given us as 2500. That means each table costs him $2500 and each chair costs him $500. Okay, also let us suppose that profit per unit that he gets from selling the table is, let us say he makes a profit of $250 from selling the table, and profit from chair that he gets is $75. Okay, also we are being, let us suppose being given that this person has total investment. He can make a total investment of, let us say, $50,000. Okay, and also this person can at most store storage capacity of 60 pieces. He can store only 60 pieces of tables and chairs in any combination. So given this thing, okay, given this example, the question is how many, let us say how many tables and chairs should he or she buy to maximize profit. Okay, let me repeat this example. We have a furniture dealer who deals in only two items, tables and chairs. Okay, he buys table at a cost of $2500 and chair at a cost of $500. Okay, the profit that he makes from table, that means each table is $250, and the profit he makes from you know the chair is $75. That means when he resells them. Okay, this person has a total investment capacity of $50,000 and he can at most store 60 pieces of tables and chairs. The endeavor of this dealer is, we need to find out how many tables and chairs should he buy to maximize profit. Okay, so this kind of question, kind of situation, in this kind of situation we use the linear programming here. Okay, so how do we go to this question, and let me write it here. Let us say, let x denote number of tables and y denote number of chairs he buys. Okay, so we want to formulate this linear programming problem in mathematical mathematical way. How do we write this problem in a mathematical way? We need to see that very thing here. Okay, now we have two variables here, x and y. These are called the decision variables here. First thing is that both x should be greater or equal to 0 and y should be greater or equal to 0. So first thing is that the variables are non-negative. Okay, so number of tables can be either equal to 0 or greater than 0, and similarly number of tables can at most or rather at least be 0 or greater than 0. So these are the non-negative restrictions. Now this dealer is concerned, or this dealer is constrained by the maximum amount he can invest, and we are being told he can invest $50,000. So I can rewrite this in this case, that is the cost of one chair, okay, times, or rather the cost of one table times the units of table plus cost of one chair, which is 500, times the units of chair, let's denote it by y. It should be less or equal to 50,000. Okay, so this person is constrained by the maximum amount he can invest. Okay, how much he can invest? At most he can invest $50,000. So this is the investment constraint for this very dealer. So investment constraint is given by, that is the cost of one chair times units of chair, cost of one table times units of table plus cost of one chair times units of chair should be less or equal to the total investment. Obvious thing is this. And another constraint he is faced with, the storage constraint, that is total number of chairs, let's denote it by x, plus total number of sorry for the mistake, total number of tables plus total number of chairs he can store should be less or equal to 60. Okay, so what is the endeavor of the dealer? The dealer wants to invest in such a way so as to maximize profit. Okay, so the endeavor of the dealer is to maximize profit. So let's denote profit by Z. And what will be the profit in this case? Simple thing. Uh, Profit from selling one table, that is 250 times units of tables, that is X, plus profit from selling one unit of chair times the units of chair. Okay, so this will be the total profit for the dealer. And what is the endeavor of the dealer? And let's write all this stuff mathematically, okay, in a formal manner. Mathematically, what is meant by this? The dealer wants to maximize Z, which denotes the profit, which is equal to 250 times X plus 75 times Y. Okay, he wants to maximize this linear equation subject to the constraint, what are the constraints that this dealer faces? That is this 2500x plus 500y should be less or equal to 50,000. Another constraint that he faces is x plus y should be less or equal to 60. Okay, these are the linear constraints. And lastly, both x should be greater or equal to 0 and y should be also greater or equal to 0. Okay, now this function, this profit function here, we call this objective function. Objective function. Okay, these two constraints we call them linear constraints or simply constraints, or we call them linear inequalities. Obviously these are the linear inequalities, and x greater or equal to 0, y greater or equal to 0, this is called non-negative restriction. Okay, here this x and y, these are called the decision variables. Decision variables. Okay, so the linear inequalities which we see here are restrictions on the variables x and y of this linear programming are called the constraints here, obviously. And these, the conditions x greater or equal to 0 and y greater or equal to 0 are simply the non-negative restrictions. So the dealer wants to maximize this objective function subject to the constraints that this dealer faces, that is the investment constraint and the storage constraint. Okay, so how do we solve this problem? We will see it in next video.